All right, so what we have not looked at yet is we have not looked at case 3, just because those take a little while. So let's look at one of those. Let's just do a simple-ish one, sine squared cosine to the 4th dx. So anytime you have even exponents on your cosine and sine, you have to do case 3. Remember, case 3 is looking at those substitutions. So the substitutions, sine squared is 1 minus cosine 2x all over 2. Cosine squared is 1 plus cosine 2x all over 2. All right, and you're just going to have to do those substitutions pretty much right away. So this integral is going to be sine squared, which I'm going to substitute as, I'm going to go ahead and just write this as 1/2 1 minus cosine 2x. That way it's not an ugly looking fraction. We got to be a little bit careful about this cosine to the 4th, right? You want to think of that cosine to the 4th as being cosine squared all squared. So it's going to be this substitution but squared. So that 1/2 1 plus cosine 2x, but then that whole substitution squared, including the 1/2 out in front. All right, let's try and rewrite this stuff all out just to see what we have. First off, we're going to have a 1/8 to pull out front. That's this 1/2. And then this 1/2 squared, which is 1/4. 1/2 times 1/4 is the 1/8. I have this 1 minus cosine 2x. Oops. And then I have this 1 plus cosine 2x squared. Not really much else that we can do here except for squaring that out and then combining as much as we can combine together. So we still have the 1/8. We still have this parentheses, the 1 minus cosine 2x. I should have warned you guys beforehand. This is a long problem, so I hope you had some paper here. Foiling this out is 1 plus 2 cosine 2x plus cosine squared 2x dx. Then we're going to multiply these two parentheses together. I'll just do that as the 1 times all of this stuff, and then the negative cosine 2x times all of this stuff. So the 1 times all of that stuff, and then the negative cosine 2x times all of that stuff. Okay. We can combine some like terms together, so let's go ahead and do that. 1. This cosine 2x and this cosine 2x will combine together just to be a single cosine 2x. We have the cosine squareds, which will combine just to be a negative cosine squared 2x. And then we have this cosine cubed, the negative cosine cubed 2x just sitting out there. Okay, and now we're going to have to kind of start over and look at different techniques. We're going to think of this as 4 separate integrals. The 1 is nothing. We can do that. Cosine 2x, we can easily find the antiderivative there. But then we have this cosine squared, and then this cosine cubed. And we're going to have to do our cases all over again. Here we have an even exponent, so we're going to have to do the same substitution we just did above. This has an odd exponent, which means we have to do the other trick. So now I'm going to go over to scratch paper, and I'm going to just find these two integrals separately. So that integral of cosine squared 2x, let's find that one, dx. So here we're going to have to do that same substitution that we just did above. So this is going to be 1/2. We have to be a little bit careful here. 1 plus cosine, but now it's going to be 4x dx. Now we have to double the angle again. Distributing the 1/2, we're going to get the integral of 1/2 plus 1/2 cosine 4x. This we can find the antiderivative of. 1/2 is going to go to 1/2 x. 1/2 cosine 4x, we're going to divide that 4, which is 1/8, and then the antiderivative of cosine is just sine. Okay, so that one's done. Still in scratch paper, let's also look at the antiderivative for cosine cubed 2x. This one we're going to have to use the case 2 technique. We're going to pull one of those cosines out. rewrite this first one using the Pythagorean identity as 1 minus sine squared of 2x. And then we could do the u substitution. Let u be that sine 2x. Du would then be 2 cosine 2x. This 2 we would have to divide over, which means that we would have a 1/2. I'll just pull that to the front of the integral. This parentheses is now 1 minus u squared. And the cosine 2x dx becomes the du once we pull that 1/2 out. We can do the antiderivative here. 1 just goes to u, minus u squared goes to 1/3 u third. Move the 1/2 back in and then redo the u substitution. Okay, great. Now we have to go back to the beginning, right? Now that we did that scratch work, now we can go back to this. So it's going to be kind of hard for me to do it all in one screen here. Sorry about that. So you'll just have to either go back in the video or go back in your own notes. I hope you've been writing along with me. That integral up top, we're going to go back and forth. We're doing the antiderivative now, so the integral's gone. The 1/8 is going to stay. Then we have the integral of 1, which is just x. The integral of cosine 2x, that 2 is going to come forward as a 1/2. The antiderivative of cosine is sine, so this is going to be plus 1/2 sine of 2x. Okay, that's going to be minus cosine squared 2x, which has this as the antiderivative. So that minus will distribute in. We're going to have a minus 1/2 x and then a minus 1/8 sine of 4x. Okay? And then a minus cosine cubed. So minus this antiderivative. And that's going to be a plus 1/6 sine cubed 2x. And then a plus c. Don't forget that 1/8 is supposed to distribute in. So we can combine some like terms together here and see what we get. The x and the 1/2 x will combine together to just be a 1/2 x. We have a 1/2 sine x and a negative 1/2 sine x. Those two things just cancel each other out. We have a negative 1/8 sine of 4x. And we have a plus 1/6 sine cubed of 2x. I think that's everything. And that's as much as we can simplify. You can move the 1/8 in if you really want to. But you can just type it in like this. I promise the homeworks will count it right once you get here. That was a super long problem. I really hope that you go through all the motions on your own. Pause the videos, rewind it if you need to at certain points to get to the final answer here. You'll definitely see something like this on the upcoming test for Chapter 8 with either odd or even exponents on the cosines and the sines. Okay, this video is still not quite 10 minutes, so I'm just going to do the next little topic real quick, and then the last topic in the last video. So the next topic is sometimes you can eliminate square roots using trig. So we'll just go through an example. I just want to do a short example for this one. Let's say you have the integral from 0 to pi over 4, and then the square root of 1 plus cosine 4x. We can get rid of the square root as long as the inside of the square root is something squared. What we're going to do is we're going to use that same identity from above here. Cosine squared x is 1 plus cosine 2x all over 2. We don't quite have 1 plus cosine 2x. We have 1 plus cosine 4x. So what I can do is I can multiply the 2 over, and then I can just double the angles on both of these. I could rewrite this as 2 cosine squared 2x is equal to 1 plus cosine 4x. So again, that was multiplying the 2 over, and then it was just doubling the angle on both of these because of the identity. Now I can replace 1 plus cosine 4x with 2 cosine squared 2x. This was coming from the identity sheet. I don't remember if I mentioned that. So still the integral from 0 to pi over 4, but now it's the square root of the 2 cosine squared 2x. Okay, and then we can take the square root of each of these separately. So the square root of 2, we'll just do the square root of 2. But then the square root of cosine squared, we'll just cancel that out. You have to be a little bit careful about canceling out square roots and squareds that way. This should technically be an absolute value. But because we know we're in between 0 and pi over 4, cosine of 2x is always positive in that interval anyway, so we can ignore the absolute value. Then we can just find the antiderivative. So we have the square root of 2 that's out in front. We're going to bring that 2 out as a 1/2, and then the antiderivative of cosine is sine. That we're going to evaluate from 0 to pi over 4. So we have this root 2 over 2 out in front. If I plug pi over 4 in, pi over 4 times 2 is pi over 2. Sine at pi over 2 is, sine of pi over 2 is 1. That's going to be minus root 2 over 2. If I plug 0 in, sine of 0 is just 0. So it looks like I just get root 2 over 2. Okay, so anytime you have a square root with trig stuff in there, try to find a trig identity that is something squared. Because if you plug something squared inside of a square root, those two things will cancel out as long as you have a positive interval, and then you can just find the antiderivative from there. All right, there's one more topic to talk about in this section. I'll get to it in the next video.